Namaskar friends, welcome to lecture number 3 in week 3, and we are today going to discuss the basic concept of robust design and design for X. But before we start our discussion in lecture number 13 overall and lecture 3 of week 3, let us have a brief overview of what we have discussed till today. So, we have tried to understand the product design process as well as have tried to learn certain skills, tools which are helpful to us in the design of a product. If you remember, I can give it as an exercise that in the last 12 lectures, name or list any 3 to 4 tools that you have learnt in the course of the lectures. So, we have already had 12 lectures and we have already learnt certain application based tools which are useful during the design process. So, right from understanding the voice of the customer or the need of the customer and trying to relate it to the technical requirements of the product, we can or technical functionality of the product, we can see that we can design a product using certain softwares which we have seen in computer aided design. We have also learnt the tool called value engineering, in which we have learnt a specific technique called DFMA, that is design for manufacturing and assembly. And if we go back, we have seen in product development concepts, that is the number 1, or product design and development concepts, that is week 1, we have learnt the product life cycle. We have learned that what is the product design process, and we have also learned that what are the characteristics that we need to take into account when we analyze the product. So, right starting from the market survey to the analysis point and finally launch of the product in the market, there are different stages, and at every stage we need to understand that how scientifically we can think about the product, how logically we can think about the product, how we can think about the product from economic point of view, how we can think about the product from mechanical engineering point of view, how we can think about the product from production point of view. So, it is a complete, we can say, overall total picture, and we have to see it in bits and pieces and then combine these bits and pieces in the form of a successful product. So, it is not a one man job or a single person job who can design a successful product. It requires inputs from various sources, and when these sources information combines together, it is able to culminate into, or the efforts of so many individuals are finally culminated into a tangible or a successful product. So, let us now see today another aspect, that is the robust design. So, some of you may be wondering that we are discussing so many different tools, but the overall objective of these tools is to make a sound design, to make a successful design, to make a design which is acceptable to the customer, to make a design which is acceptable to the market. So, our overall efforts, for example, we can say, take an example from the value engineering background, the fast diagramming approach, the computer aided design, the quality function deployment, the product life cycle, all these are tools which will help us in the successful design of the product. So, each of them is interconnected, and this overall knowledge about the concept will help us to come up with a successful product design. And in that series, we can now think of discussing the robust design, that now till last 12 lectures we have seen that how the ideas can come, how to nurture those ideas, how to segregate those ideas, and then we have seen that how we can achieve the function. We need to have different alternatives, then we will select one or two alternatives. When our alternatives are ready, we will give them some shape that can be done using CAD software, in which we can do the geometric modeling or the drafting. So, we have now a shape ready with us, and we have to see that when this product will be launched in the market, what type of conditions conditions it is going to undergo, and then we have to see that its performance should not get affected because of certain factors. So we will now see that how we can make our product robust, that it is able to perform under different types of operating conditions. So robust design basically is a design which is not influenced by the different parameters through which it is subjected. So when we are designing a product, we have to ensure that it is uninfluenced, it is independent of the various parameters that may affect its performance, and that we will try to understand with the help of example. So once the design is ready, we have to incorporate all these things that are related to the performance of the product. Right now we were focusing on the functionality, we were focusing on the shape, the size, we were focusing on the color. So we have seen so many different parameters related to a product design, but now we will focus, our discussion will slightly move towards the second part, that is once the product is launched in the market, how it will perform. So its performance we have to foresee, and we have to design it in such a way that it is able to perform its functions properly, or it's able to deliver the requirements for which the customer is going to buy our product. So for that we have to see that what are the tools and techniques that we should keep in mind, so that the product delivers when it is called upon to do its intended job or intended function. Moreover, we have also to ensure that when this product is fabricated, it is assembled, it is manufactured, the cost should not increase exorbitantly high, so that the product loses its competitive advantage in the market. So therefore we have to see that how all these parameters are important, how to control these parameters so that our product is successful or is successfully launched in the market. So all these things have to be taken into account during the design stage only. So this is a slight background there, so that our audience or everyone who is attending this course is able to correlate that we are not discussing topics independently, all these topics are integrated into one common thread, that is the product design and development. Now let us see that how we can make our product robust, and what do we mean by a robust design. Now a system, in our case it is a product, is robust if it performs properly in a wide range of conditions. So robust means it should be able to sustain under different conditions. Usually we say he has got a very robust body, which means that the effect of temperature and humidity and sweating and little bit of cold does not affect his body. It means the body is insensitive to changes in all these conditions or all these environmental conditions. So the robust body, usually we say, sometime for an automobile also we say that that particular automobile has got a very robust body. So robust word, from we can say literal meaning, is maybe strong and sturdy, and it is not influenced by the variations or changes in the parameters. So a product is robust if it performs properly in a wide range of conditions. Now let us take some examples of robust products. A pen that writes until the ink is empty can be considered as a robust product. But if the pen stops writing after a few months, still ink is there in the product, we can also say that this product is not a robust product. This can also be related to the concept that we have already discussed during our product analysis stage, where we have seen durability, dependability, reliability. So these parameters can further be correlated to these parameters. Maybe this particular example can be given for durability, dependability also. A car that starts at minus 20 degrees centigrade can be said as a robust design. Why? Because it is not getting influenced by the temperature, which is sub-zero temperature. But a car that does not start at this temperature, we can say is not a robust design, because it is, we can say, influenced by the very low temperature. Then a vacuum cleaner that maintains suction levels can be said as a robust design. A vacuum cleaner that loses the suction can be said as is not a robust design. So these are just illustrative examples to try to understand that what we can call as robust. So we can call a design robust if it is not influenced by the parameters or the uncontrollable parameter. There will be some parameters which we can control, but our product should be such that it should be able to sustain different types of parameters. It should be insensitive to the variations in the various types of parameters on a broader scale. So we will try to understand what you do the robust design take into account. In the design of a new product, any design activity can be called robust if it leads to. Now we have to see that how we can design a robust product. We have to ensure that it has a long life. As I have already told in the example of a pen, it can also be related to reliability, which we have already discussed in product characteristics. It should be consistent with use. It should not happen that maybe after a specified period or after a specific time the product starts to dysfunction. So that has to be ensured. Maybe it has to perform consistently. To be more consistent from product to product, so there should be consistency level of performance for different products. For example, a company is manufacturing shoes, so each product or each different product coming out from the company should be consistent in quality and performance. To perform consistently as temperature and other conditions change. That example already we have taken of a car, that if it is able to start at minus 20 degrees centigrade, we can say yes, it is a robust design. So it is not getting influenced by the changes in the temperature. So it should perform consistently under varying conditions. So we can say we have to incorporate in our product all these characteristics so that the product performs robustly. Now, general rules for a robust design, how we can ensure that the product will perform in a robust manner. Now, let us see. Always identify critical characteristics that quantify customer satisfaction. Now, let us take an example of a shoe. What can be the customer requirements from a shoe? First thing is it should be comfortable to wear. So for some customers it should be light in weight, then it should be pleasing to the eyes. So maybe these are the 2 or 3 important customer requirements from a pair of shoes. So we have to identify that what are the critical characteristics, and then we have to ensure that all these critical characteristics are met so that the product is robust. So always identify critical characteristics that quantify the customer satisfaction, and then always look for ways to reduce variation in these critical characteristics. So from a robust design point of view, if I am buying a pair of shoes and my critical characteristic is that they should be comfortable to wear, now maybe after 6 months or after 7 months, suppose I find them uncomfortable or maybe itching, or there can be other problem that they have become loose, I will say no, they are not very comfortable shoe, and the designer has not incorporated the concept of robust design into the shoe. So why? Because now it is changing with respect to time. In many other cases there the design may perform poorly because of the environmental conditions, sometimes with respect to time, sometimes with respect to other factors which are beyond the control of the customer. So we have to ensure that the product that we design should perform reliably with the duration for which it has been designed. So in order to incorporate that, we have to see that what the customer wants, and that thing should not be compromised maybe over a period of time or under specific set of conditions. Like we have taken the example of a car, in which we have seen the car should start even at minus 20 degrees centigrade also, and it should start at maybe plus 47 degree temperature also. So this variation of temperature should not affect the ignition of the car or the starting of the car, and if the design ensures that, it means we can call it as a robust design. Now let us see the robust design in detail. Robust design is a concept developed by Dr. Genichi Taguchi. Taguchi's methodology I think is important for every engineer. It is defined as reducing variation in various product characteristics. So the variation because of which the product may become unusable, that has to be reduced. In other words, making the product or process insensitive to variation. So we have to ensure that that variation should be minimized, or the product performance should be consistent, independent or insensitive to the variations, that we have to ensure. This variation can come from a variety of factors. Sometimes they are called as the noise factors also. So we will see that what is a noise factor and what are the controllable factors. So let us further take the classification of the noise factors. You can see three types of undesirable and uncontrollable factors can cause deviations from the desired performance. Now these are called different types of noise factors. Now first one is external noise factor. Operational environmental variables such as temperature, humidity are examples of external noise factors. Example already taken. Internal noise factors, the problems caused by deterioration such as wearing of parts, manufacturing imperfections like machine setting extra, are internal noise factors. Now in internal noise factors we can say that suppose we are machining a shaft and we are using a single point cutting tool to turn the shaft. Internal noise factor can be that over a period of time the work holding device and the tool holding device has worn out and there is little bit of movement between the tool and the workpiece, which is spoiling the surface finish of the product. Now because of this wear and tear of the work holding and the tool holding fixture, we are not getting the desired performance. Under ideal conditions or a new machine, the tool and workpiece would have been absolutely at their place and the performance would have been consistent and we would have got the desired level of surface finish. Whereas with the worn out parts we are not getting the desired performance. But since the parts are worn out, they may not be in our control. Why? Because this would be one of the outputs that the surface finish is not good, and then we will see what can be the variations, and sometimes this variation may not come to our mind also, that the surface finish is poor because of the wear and tear of the machine elements, and therefore we can say that they sometimes turn out to be the noise factor or the random variables or the uncontrollable factors. So I think external noise factor, temperature example already taken, internal noise factors, and unit to unit or variational noise factors. It indicates the difference between individual products which are produced to same specifications. Now suppose, taking a simple example, I have to travel from Roorkee suppose to Delhi by bus. So suppose I go 10 times, every time there will be a difference. The journey remains same, the distance is same, the mode of transport is also bus, but because of the parameters, number of parameters like the traffic or the fog or we can say some traffic jams or some accident on the way. So because of so many uncontrollable parameters which are beyond my control, the time will always be different, and all those type of variations can be indicated. It indicates the difference between the individual products. In my case, it is a journey from Roorkee to Delhi, which are produced at the same specifications. Specifications remain same. I go by bus, I start at the same time, maybe 10 o'clock in the morning from Roorkee, but my reaching time at Delhi will always vary, all other factors remaining same. So that difference can be explained by the variations which are uncontrollable variations or noise factors. So basically, as a product designer, I should always, or I must always ensure that the product is consistent in its performance and is not affected by the variations in the noise factors. Well, let us see now. Taguchi, Dr. Taguchi suggested a robust design method. What is that robust design method? It is a systematic method for identifying process parameters that are more sensitive to inherent process variation and minimize the effect of causes of variation. So we have to identify the process parameters that are more sensitive to the inherent process variation and try to minimize the effect of these parameters so that the product is consistent in its performance. The primary goal of the robust design is to evaluate these losses, or maybe to find out these losses because of the noise factors, and determine the process conditions that would assure the product manufactured is initially on target, and the characteristics of the product which would make the performance insensitive to the environment and other factors. So, we have to see, we have to ensure that the product manufactured is initially on target. So, first we have to ensure the quality of the product, and the characteristics of the product we have to ensure which would make performance insensitive. So, the performance becomes robust, it is not sensitive to the variation of the noise factors. Those noise factors can be environmental or other factors. So, I think this I have already sentence, or these two sentences I have already summarized in a single sentence only, that as a product designer we need to ensure that our product is insensitive to the variations of the noise factors, and if we can ensure that, then the product becomes acceptable, the product becomes successful, the product is appreciated by the customers who are going to use that product. Now, designing performance into product, we can see how we can ensure that the product can be made robust. Let us see, the Taguchi has recommended 3-stage process for building performance and quality into the product, in totality making the product robust in its performance. The 3 stages are system level, parameter, and the tolerance design. Now, let us just read this, and then I will try to explain this with the help of an example. So, at system level, already we have seen the functional design. We have already engaged week 2 on value engineering, and functions we have discussed in much more detail. So, I will not go to functional design again, I will try to explain this with the help of an example. So, this is a first step in the design, and it makes use of the technical knowledge to reach the initial design of the product. So, at this stage we will only go to the initial design of the product that delivers the basic desired function performance. So, first thing is the basic functional design of the product. For example, if you have used the table lamps which were used for studying during the odd hours, or maybe when combined their roommates sharing a room, everybody will use a table lamp to study. So, the table lamp functional design was a simple design, 2 links, a holder and a bulb there. But now you see the design of the table lamps, there are so many varied designs available, aesthetically well designed, functionally well designed. So, first step is to ensure the basic functional design of the product. This includes the design system, subsystem, and finally the elemental level design. So, this I have already told. For example, the bridges that we see in India, most of the bridges are the basic functional bridges only, ensuring that the traffic can pass over the bridge. But if you see at a higher level, you will see certain bridge designs which are not only functional but aesthetically also pleasing, and maybe sometimes maybe having additional functionality also. So, first design level is the elemental level design or the functional level design. Second is the parameter design. This step aims at finding the optimal setting of design parameters. At this stage, to obtain the optimum parameters, a physical or mathematical prototype is built for the product based on the functional design. Now, next stage would be the setting up of the parameters, the specifications of the product, the size, the shape, and other parameters will be finalized at the parameter design stage. And the last stage is the tolerance design. In this step, the tolerances on the product design parameters are determined considering the loss that would be caused to society when the performance deviates from the target. So, right, going from the society, we can say caused to the customer when the product will not perform its function reliably. Once the system has been designed along with the values of parameters, the designers has to set the tolerance of the parameters. So, we will see that at what range we have to set the parameters. In tolerance design, the manufacturing tolerances that minimize the effect of the noise factor and manufacturing cost is determined. So, there are 2 parameters here. Manufacturing cost is one parameter, and the effect of noise factors is the second parameter. So when we are setting the specifications or the tolerance range, we have to ensure that the design is insensitive to the noise parameters. So insensitive, maybe you know what is insensitive, that it is not affected by the noise factor. So these are the two things that need to be ensured during the product design process when we are ensuring that the design is going to be robust. So manufacturing cost as well as the noise factors. Now let us take an example of a water bottle to explain these 3 points, that is system level, parameter level and the tolerance design. So little bit confusing, but let us try to understand it with the help of a design of a bottle. At the first stage, that is the system stage, we will see that we have to design a bottle. What is the functional requirement of the bottle? We can say verb and a noun: carry water or carry liquid. It is not that only water will be, it can carry, maybe sometimes we use the same plastic bottle for bringing oil or petrol. So it can be, we can say, for a bottle the functional design is carry fluid or carry liquid. Now the first part can be functional design. Now the second part, that is the parameter design, we need to ensure what will be the exact shape of the plastic bottle, what will be the color of the plastic bottle, and then what would be the capacity of the water bottle or the fluid bottle. So we have to ensure all these parameters for the design of the product. So first stage is concept design or the functional design, that is it has to be able to carry the fluid. Second is that it should be able to carry a specific quantity of fluid, it should be able to look good, it should have a specific shape, it should have a shape which can be held very easily. So that is a parameter design. And at last stage, that is the tolerance design, we will see that if it is manufactured, what can be the tolerance given to the mold in which it is being manufactured, so that it is consistent with the performance. Performance means it is supposed now to carry maybe 1 liter of the liquid. So it should not happen that the dye is designed in such a way that it is only able to carry, instead of 1 liter, it is able to carry less than maybe 2% or 1% less liquid as compared to the actual design. So we have to ensure. Second, maybe a tolerance design stage, we have to see that when the bottle has to be closed by the cap, the threads inside the cap and on the outer periphery of the bottle are consistent to each other and follow the concept of interchangeability, which means that this bottle, any sample from the bottle and any sample from the caps should be able to assembled to each other. So that is the concept of interchangeability. So we have to set the tolerances in such a way that the performance of assembly of this bottle and the cap is done properly and there is no error in that particular thing. So from the functional design to the parameter design to the tolerance design, this will ensure that the product is robust and it achieves its target for which the product has been designed. So if we are not taking account at each stage the concept of robustness, sometimes at a later stage the product may face a problem. Sometimes it may so happen the bottles that we are producing are not to the required size, and in some cases the quantity is more than 1 liter and in some cases the quantity is less than 1 liter, and then your overall you can say authority is challenged, or overall authority in the market for that brand, it gets challenged. So it is always advisable that we should ensure robust design of the product. Now this is a simple example, very quickly I will go through this example. An automobile manufacturer wants to improve the quality of the painted surface on its cars. So there is an automobile company, there is a paint on the car, the quality, the manufacturer wants to ensure that the quality should be excellent. The quality is measured by the gloss reading on the surface. So there is a instrument which measures the gloss reading on the surface. The manufacturer wants the painted surface to have a higher gloss reading, which means that the instrument that measures the gloss reading, it is expected that the maximum gloss reading should come in order to ensure the quality of the painted surface and to be robust against the environment. So it should be robust against the environment over a period of time. It should not get influenced by the environment. The environmental factors, particularly temperature and humidity, are known to affect the painting surface. Thus, a robust design will be used here. Now, we have to ensure that even if the car is parked in the open or it is subjected to the temperature or direct sunlight, the surface should not get influenced. Now, what are the parameters that we can control? We can control few parameters. Now, while depositing the paint on the surface or on the body of the car, we can control the flow rate of the gun, flow rate of the paint. We can control the pressure in the paint gun, the viscosity of the paint gun, and the cure temperature. So these are the 4 parameters that we can control in order to deposit a paint which gives us the maximum gloss reading. But there are few parameters which are out of our control, that is the temperature and humidity for depositing the paint on the surface. Now 4 parameters are within our control for depositing a good quality paint on the surface of the car body, but there are 2 parameters during the process which are beyond our control. So in order to improve our process, what we can do? We can control these 2 parameters also by making our paint shop air conditioned, so that we can control the temperature also, we can control the humidity also. But currently maybe the manufacturer who's using a paint shop may not be able to control these parameters. So if the parameters are beyond the control, we call them as the noise factors. If it is an air conditioned room, we can control air temperature and humidity also, they also become the controllable parameters. Then if there is a variation in the paint during service, it can be because of certain other uncontrollable parameters, which can be the bonding between the paint and the body. It can be certain parameters which are random in nature, which can be anything ranging from the skill of the worker to maybe the adhesion between the paint and the body. So different parameters can be there which are right now maybe beyond our control, but if with proper investigation and research can be brought into control. But as a product designer, my aim should be that I have to ensure a design which is robust in nature, which is insensitive to the noise factors, and it delivers when it is called for to deliver the intended function for which the design has been put into place. So with this we come to the end of our lecture number 13, and I have tried to just introduce the concept of robust design with the help of an example. We have tried to understand that there are a few controllable parameters which we can control, there are a few uncontrollable parameters which we cannot control, and our product or process should be designed in such a way that it is insensitive to the uncontrollable parameters or the noise parameters. In next lecture we will start our discussion from design for manufacturing and design for assembly. We will see what is DFX and where do DFM and DFA fit into the concept of DFX. Thank you.